When people say GPT, they say it like it's one single magic thing. But there's a whole zoo of model types out there. And most of the chatbots you've heard of are secretly the same animal. Today, we walk the zoo.
That's the right way to think about it. The word GPT sounds like a product, but it's really a description of a shape. Once you see the shape, half the mystery goes away.
Okay, so spell it out. What does the name actually stand for?
Generative, pre-trained, transformer. Generative means it produces text. Pre-trained means it learned from a giant pile of text first. And transformer is the architecture underneath. Strip away the marketing and the whole job is one thing. Predict the next token. Over and over.
And that's true of the others too. Claude, Gemini, Llama, all of them? You keep saying decoder only, like there's more than one kind of transformer.
Mostly, yes. Claude, Gemini, Llama, Qwen, Mistral, DeepSeek are almost all the same backbone, that decoder-only transformer predicting the next token. And to your question, decoder-only is just one of three classic shapes. They all come from one paper.
Start with the one I already know, the GPT kind.
Decoder-only models read left to right and can only see what came before, never ahead. That's perfect for writing, because when you're generating, you genuinely don't know the future yet. This is the GPT family, and it's what runs basically every chatbot today.
Now the second one. You mentioned BERT. What's different about it?
Encode-only models, like BERT, get to see the whole sentence at once, both directions. That gives them deep understanding. They're great at classification, sentiment, search relevance, and turning text into embeddings. The catch is they don't generate. There's no chatbot mode. They read, but they don't write.
And the third one, the original full version with both halves?
Encoder-decoder keeps both halves. The encoder reads and understands the input. The decoder writes the output. That's a natural fit when you turn one text into another, like translation or summarization. The original transformer worked this way, and T5 is the well-known example.
So if decoder only can't even see the whole input at once, why did it win the chat race?
Two reasons: simplicity and scaling. The training is one clean game, guess the next token. So you can pour in essentially the entire internet without hand labeling anything. And it just keeps getting better as you add data and parameters. Chat turned out to be a generation problem, and the generators scaled the best.
So is that the whole zoo? 3 cages, and we're done?
Not even close. The three families are the classics, but the interesting modern animals are variations and add-ons. Let me show you 4 that matter because you're using all of them, often without knowing it.
First one, mixture of experts. I hear that constantly now.
Mixture of experts, or MOE, splits the model into many smaller expert subnetworks. And for each token, only a couple of them switch on. So you get the knowledge of a huge model, but the running cost of a small one. It's how a lot of the big models stay cheap enough to serve.
Next up, multimodal. That's the ones that see images?
Right, a multimodal model takes more than text. Images, audio, sometimes video. The trick is converting a picture or a sound into the same kind of tokens the transformer already understands, so it can reason across all of them together. Same backbone, just fed more senses.
Third, embeddings and rerankers. These are the quiet ones behind search, right?
Exactly, the quiet ones. An embedding model turns text into a list of numbers that captures meaning. So similar ideas land near each other, and you can search by meaning instead of keywords. A reranker then takes the top hits and resorts them for relevance. Together, they're the engine under search and retrieval, what people call RAG.
And the last one. You said there's a challenger to attention itself?
There is. Attention is powerful, but its cost grows fast as the input gets longer. State-space models, like Mamba, take a different route that scales more gently with length, which is promising for very long inputs. It's early, but it's a real alternative to the attention everyone's built on.
So pull it together. If the architectures are mostly shared, what actually makes one chat model better than another?
So here's the punchline of the whole zoo. Almost every chat model you've heard of shares one backbone, the decoder-only transformer. So the things that actually separate them aren't exotic architectures. It's the data they learned from, the scale they were trained at, and how carefully they were taught afterward.
So next time someone calls GPT magic, you can tell them it's a next token predictor with a very good education. Next time, we'll get into how that education actually happens. Thanks for watching.